Why did you choose this case study?
The evolution of anti-pollution requirements impose emission not to be exceeded. New requirements concerning anti-pollution have prompted automotive manufacturers to change their technology. That's why we want to be aligned and to follow the same route. So we have chosen this case study that is a motor cradle that belongs to an electric vehicle.
Explanation of details related automotive case study for ConstructAdd projects.
Yes, we start with one engine cradle that was composed of 33 components and weighs 26 kilograms. So our goal with this project is to combine the traditional tube forming with the additive manufacturing technology to optimize parts in order to reduce the number of components and also to be competitive with this component.
What have you done so far? What remains to be done?
Up to now, we have worked in 3 different cradles. So we discarded the first 2 because they were not competitive. So we start working with this last 3rd design. So together with Politecnico University, we are optimizing this design. We are starting doing an iterative design and simulation process. So once the design cannot be further optimized and the simulations are valid in terms of our specifications or in terms of the customer specification, we are going to have our final cradle design. So once we have the design, the idea is to manufacture the demonstrator. In this case, Arcelor Mittal is going to be in charge of manufacturing the tubes, and our colleagues of the consortium will print it. We are going to print the 3D printed components, and then we are going to assemble all the components in our factory of P3 to have the final demonstrator.
What is the role of life cycle assessment and life cycle costing in additive manufacturing research?
Within the life cycle assessment and life cycle costing, we can evaluate and quantify the environmental and economical impact of the additive manufactured product in a whole life cycle and in all phases, well as raw material extraction, manufacturing, production, use and maintenance, waste treatment, and end of life. Moreover, with the hotspot analysis, we can understand which are the activity and the process that mainly contribute with the environmental impact, and then we can identify the environmental optimization scenarios.
What environmental optimization scenario are you defining for metal additive manufacturing?
Analyzing the impact of ConstructAdd demonstrators case study with the industrial partner of the ConstructAdd consortium, we are considering the environmental impact reduction with circular strategies like increasing recycling content and also the reusability of steel powder and product. Moreover, with the industrial partner, we are evaluating the impact of different gas atomization and the possibility of change the mix of steel powder composition to reduce the impact.
What are the opportunities to apply the MAM sustainability assessment within the ConstructAdd project?
ConstructAdd project gives us the opportunity to consider the environmental optimization scenarios in terms of design and in terms of process. In fact, compared to the traditional product, we are evaluating how the design and the geometrical optimization can reduce the consumption of raw material and the manufacturing time. And then, in comparison with the traditional metal working, we are evaluating how we can improve the additive manufacturing and reduce the environmental impact and economical impact.
What is the key role of MIMETE in ConstructAdd project?
MIMETE is a metal powder manufacturer for different applications as LPBF technology and LDID, HIP and others. So main tasks of MIMETE in this project was to produce actually the powder, so the feedstocks for LPBF technology and for LDID technology. At the beginning, we started with the first batch production. The materials obtained from this first batch was used and was tested by our consortium partners, and after a successful results, it was possible to go ahead and to produce the second batch with a huge amount of powder. For sure, it is important to maintain and to have the results in compliance with the initial requirements.
Did you have some struggles to overcome, and eventually, which were the most important challenges during the feedstock production?
Main challenges were to find a good compromise between the initial requirements and the real feasibility of this material. What do I mean? Actually, sometimes we are asked to maintain some elements as low as possible because this is desired for the properties of the final product. But it is important to keep in mind that some of these elements are really crucial for the feasibility and the producibility of this material. So these one were the main important ones.
What are future perspectives and what makes attractive the additive manufacturing technologies on the actual industrial market?
As in every new technologies, for sure also the additive manufacturing technologies has some important challenges to overcome, but thanks to enthusiasm and thanks to professional people as the ones involved in this consortium project, it is possible, thanks to their dedication also. And what is interesting, what we see nowadays, that it's important also the green production. So actually what we had the possibility in this project is to try to reuse, so to recycle some materials produced in the first batch. And it is interesting that the results actually have not shown any side effect on the final results, both from chemical point of view and from the physical point of view. So actually this is quite interesting.